So, very good afternoon, everyone. Today, we will be looking at a very advanced topic that is transfer learning. This is something which many of you might have heard about, but it's really an interesting topic that we will come across in the future because uh, we all have uh, heard well enough about machine learning. So let's actually have a look at what exactly is this. So I have a small presentation which I will be presenting it to you. Okay, I will share my screen. Then we'll go about. Uh, okay, yeah. So this is the topic that is transfer learning. So we can just see what exactly is transfer learning. So if you all know uh, what exactly is machine learning, right? Then you would have an idea what exactly is transfer learning. In machine learning, what do? We train a particular system to recognize certain objects or recognize certain things, whether it is an object recognition or whether it is, you know, solving any complex problem. We train the system to do some job, so a particular task. We give different inputs, say for example, image recognition or recognizing people in an image, classification of people or recognizing people in a given scenery. So is it possible to do by machine learning? Definitely yes. So we say a set of around 1000, 20,000 images we feed into the system. We uh, train the system to recognize the images, the people in the images, and then we give the output. From the output, we understand that okay, in a particular given image, there are so many or these many people are there. So this well works well with classification and regression problems and all that. So we'll have a look at what I was telling is shown over here. So if we just have a look in this particular image, okay, this is a very practical thing. So you keep on training, you keep on training. You know that whenever there is an image, so there is a human being. A human being is detected in this image, in all these images. So what happens? You have trained a machine learning model and it recognizes just the images of pedestrians, the people walking. Say you have continuously fed only images of pedestrians. So the machine learning model is such that it is able to recognize with enough accuracy only the people who are walking. All right. But what about people who are pedaling, people who are going on a bicycle? This particular model that you have trained is definitely not going to detect those people. So what to do then? What else to do? This is the question. So there is a very important algorithm, a very important way of learning called the transfer learning. Okay, every time you do a training, train a model, it's very cumbersome. It takes huge amount of time to do this job. Okay, it takes a very large amount of time in not just time, it is computationally heavy also to do this computation, especially if you're doing it on a processor like a DSP processor or a simple ARM processor and all that. Okay, it's not processing power is not sufficient enough for you to do the training. Say the example of this training itself. Say you have a 20,000 set of images. Okay, you feed it into the model takes a lot of time to do it, and apart from that the amount of power it consumes, all this is very high. So you need specialized GPUs to do these kind of high amount of processing. Simple processor would not do the job. Since a simple processor would not suffice, every time you want to solve similar problems, now for this particular problem, if you want to even detect even the bicyclist, there's a simple job you need to do. You don't have to do the training for with a set of bicycle people who are riding the bicycle. Those images you don't have to feed. Okay, you can actually transfer this learning that you have done to find out the pedestrians, whatever you have trained the model, the same model could be transferred or used in a little different way by tweaking certain things. You could actually use that particular image or that particular model to train images with. You really don't do a complete training from scratch. That is the basic idea. You do some adjustments with already present knowledge. So the basic thing here is there is already something ready made to you. Okay, you are just building upon that. Transfer learning is all about that. See, when something is already there, it's like you already have see, you have a packet of ready to eat, something which is ready to eat upma, ready to eat poha, and all that. All you have to do is what? You are not going to make the upma right from the scratch. You're not going to take roast the semolina and put all the vegetables, cut the vegetables. You're not going to do that. It's already there in the packet. Transfer learning is similar to this. Okay, you really don't start off right from the scratch. There's already something, but you make certain adjustments. Like ready to eat upma is there, but you're not really happy with that upma. You want to say instead of making it salty, you want to make it sweet. So what you can do about it? So what could you do? You want a kesari bath, which is a very famous sweet in South India. Okay, you want kesari bath out of that because some vegetables will be there. You'll have to do a little customization, remove those little pieces, and instead of there might be a little salt, add extra sugar, jaggery, and ghee and everything, and probably you convert this ready to eat upma into a kesari bath. This is what we are going to do. This is all about transfer learning. So that's it. So super learn, supervised, it's a supervised learning. Supervised learning is where there is a teacher teaches. Unsupervised learning is whether there is no teacher and there's no one to tell you what to do. You just learn on your own and things happen on its own. So the very pioneer of this, Andrew Ng, has told that transfer learning will be the next driver of the machine learning. How well machine learning can succeed depends upon this. Okay. So, as I told you, building a model from scratch is very difficult. And on top of that, you could use already successful models in solving certain problems, which are very successfully used. You could really use those particular problems to, solve some other problems where you do not have enough data, you do not have enough time to do the labeling, you have a lot of privacy concerns, so many problems. In certain cases, you may not even get enough data to do the training. So in all these cases, you could go for transfer learning. You could use a model which is machine learning model which is already there, and you can build upon that. So major assumptions in traditional machine learning is that you have a feature space and some data distribution. So use this data distribution over the space and you try to figure out how to train the system. So certain examples that could use your transfer learning is given in this one. So for example, image classification, you're recognizing some cats. You have so many images for cats. So you have trained a model to recognize the cats. You could use the same thing for radiology diagnosis. Can you imagine that? Provided you have to do the training perfectly. You have to tweak the weights of the model in such a way that because for radiology diagnosis you may not get sufficient input parameters, input images you may not have, and the variability in the data will be very less. So that many radiology images if you don't have, then how will you train a model from scratch and uh, deploy it successfully? So when you can't do that, you could use an already trained model which successfully works on recognizing cats, okay, for this. So only thing is, you could use this model which is used for training the or recognizing cats to do this. The reverse, you may not be able to do the reverse because you've already tweaked the weights. You may not be able to do the reverse. So this is it. So at this point, whenever you have built the model, say task one first was recognition of cats, you could do the same for task two, that is radiology. You could transfer the knowledge. Okay, you could transfer the knowledge. You could transfer the knowledge and the model one. Say the same model is used here, and there is a new dimension you're giving. That means there are certain layers in the transfer learning that you're going to change in your model, that you're going to change. So this is it. This is how it works. Some layers which are here, you're going to remove it and you're going to do it. So something like image recognition, you could, and radiology diagnosis. Okay, whatever is stored, that is, this is it. Okay, similarly, even for speech recognition, you could do this. So just imagine all this is something which is very much interesting. So basically, anything you take, there's a domain where X is your feature space and P of X is the marginal probability distribution. It is the probability distribution. So any domain you consider, it is a domain is equal to X comma P of X. This is how you represent it. So always make sure that your source and target is not same. The probability distribution is different, the output is different, and the conditional probabilities are also different. So let me skip a few of these. So these are the steps. You will load the weights of the pre-trained model, remove the few output layers, attach new layers, hold the weights, then train with the new data set. That is, for example, if it's the radiology images, you just feed whatever data you have because model is already there. And since you have removed new layers, you have removed few layers and you have attached new layers. So the problem of recognizing cats has changed to problem of recognizing or diagnosing your radiology images. So whatever you have learned here, this you transfer it to some other model which you could deploy practically. These are few examples. Some simulators, some simulator which was used, a model which was used to simulate some self-driving car. The same thing could be used for training the robot. From that particular simulation, that model is used to train a robot. So that's a great example. Similarly, they, there are a lot of examples that you can come across. It is like you in one domain, it's just the bicycle, but whereas in another domain, it's with a lot of variations. They've just given a comparison. Okay. So the advantages, as I told you, it needs very less training. Very well, it generalizes and it's very easy to debug because you exactly know where is the change, where exactly the change has to be made. You know exactly where you need to tweak the weights, right? So thank you. So this was a small overview about transfer learning. I hope you enjoyed it. Okay, let's go through. Let's take up another new topic for technical aptitude session. Hope people will do more projects on similar basis. At all you have a machine learning model or machine learning models are already available, take a unique problem and try to apply this particular model into this particular technique, transfer learning into that. It'll be very interesting. And if you're good at coding, you could implement it using Python. Okay. Not just Python, you could even do it on MATLAB. So all the best. Try to figure out a problem, and I'm just definitely looking forward that at least few of you will use this idea and build something really innovative. All right. Thank you. Thank you, students.